Hey guys, today's video is about model evaluation. We've discussed accuracy, error rates, and the class imbalance problem in the previous videos, so we'll focus on sensitivity and specificity today. To recap, accuracy and error rates are biased, especially when the classes are not balanced. That is, the outcomes are not evenly distributed in the data. Here's an example of medical test we've looked at. This dataset is imbalanced, with 300 data points in class positive, 5,150 data points in class negative. If the model predicts all people as negative or healthy, then the accuracy is 0.945. This accuracy makes the model look great, but the model is totally useless. In specific, the accuracy for class positive is 0, because everyone is classified as negative. However, what we actually care is the positive class, which contains people with disease. The accuracy doesn't reflect the poor performance in class positive, because it only measures the overall performance. Therefore, we need other measures to solve this problem, and that's why we introduce sensitivity and specificity today. Okay, so sensitivity is the percentage of correct classification among the data points belonging to class positive. If you remember, the accuracy is the percentage of correct classification among the whole dataset. Therefore, the difference between them is that sensitivity only cares about the class positive. The formula of sensitivity is Tp divided by P. P is the data points that belong to class positive, so it's Tp plus Fn. Fn is included because it represents the data points that are positive, but incorrectly classified as negative. As you can see, we ignore the negative data when measuring sensitivity. However, for specificity, we only care about negative data. By definition, specificity is the percentage of correct classification among the data points belonging to class negative. In fact, we can think of specificity as the accuracy of class negative. Although sometimes we only care about class positive, we need to make sure the model won't misclassify a lot of negative data as positive. The formula for specificity is Tn divided by n. N here is the data of class negative, which is Fp plus Tn. A quick summary: sensitivity is the accuracy of the positive class, specificity is the accuracy of the negative class, and accuracy is the percentage of correct classification. Alright, let's look at an example. This is the example from the previous video, and the accuracy of this model is 0.936. The problem is, the model performs poorly in the class positive, but accuracy fails to reflect this issue because it only measures the overall performance of the model. That's why we need sensitivity and specificity. Sensitivity is the accuracy of class positive, so it's just Tp divided by Tp plus Fn, which is 1/3. As you can see, the sensitivity is low and unacceptable. In fact, if we make a random guess, we'll get sensitivity around 0.5 because we have 50-50 chance of guessing right. Why would we need a model with sensitivity 1/3 considering it performs worse than a random guess? Therefore, sensitivity helps us realize the model is unacceptable due to its poor performance in class positive. Now we can look at the specificity. Specificity is the accuracy of class negative, so it's Tn divided by Tn plus Fp, which is 0.971. In other words, the model performs almost perfectly in class negative, but don't get too excited, sometimes it's because of the nature of data. For example, in a medical test, most people are healthy, and if the model classifies most people as healthy, then it would get a high specificity. This brings us to the next topic, the trade-off between sensitivity and specificity. By trade-off, we mean the high sensitivity often represents the low specificity, and the high specificity often represents the low sensitivity. Let's look at an extreme. Suppose we classify all people as healthy in a medical test, then we get a confusion matrix like this. The false negative is 300. That is, people who have disease but being classified as healthy. And the true negative is 5150, which are the number of healthy people. The sensitivity is 0, because everyone with a disease is classified as healthy, and the specificity is 1, because every healthy person is correctly classified. In fact, 0 is the minimum sensitivity possible, and 1 is the maximum specificity possible. Again, if we think about the purpose of medical tests, we'll find the model useless, because it classifies all people as healthy. The thing is, if we only look at the specificity, we might believe the model performs fine because the specificity is 1. Accordingly, we should always look at multiple measures to determine the performance of a model and not be fooled by a single number. Further, there are more measures can be referenced, and we'll introduce them in the next video. Alright, this is the basic idea of sensitivity and specificity. Thank you for watching my video and see you soon.